Hi, everyone. Welcome to session 12C, Data in Motion. It's my pleasure to introduce our speaker today, Ashish Verma. He's the Data and Analytics Modernization Market Offering US and Global Leader of Deloitte Consulting's Analytics and Cognitive Practice. And that enables clients to plan and execute new businesses, new strategies with technology innovation while driving analytics into day-to-day operations, evolving key data and analytics capabilities to meet changing market dynamics. He has 23 years of consulting experience leading data and analytics technology projects. So Ashish, it's all yours.
Thank you, Ben. Hopefully you're going to be able to see my screen shortly, and let me know if you can.
Yes, we can.
Perfect. So I figured, we'll sort of give you a flavor for what this is and why this is mainstream. As Wayne said, my role in the portfolio, both for the US and global firm, has been to start to innovate what's happening in the marketplace to broadly deliver to the mandate of both data and AI. And if you look at the evolution of the portfolio that I've been at the helm of for the last 7 years, I can tell you that it has morphed itself from on-premise to sort of like the genre of big data, where we built a good amount of storage on Hadoop distributions on-premise. The next wave of which was get this to the cloud, to the hyperscalers, AWS, GCP, Azure, to a certain extent PaaS services on those as well, i.e. Snowflake, i.e. Databricks. And then really the last about 18 to 24 months, how do you realize the value of AI and hence what it means for us from the standpoint of data in motion. So I'll share a short video and hopefully that'll start to inform sort of what do we mean by data in motion. This will take just a second to load. All right. Hopefully that sets some context for you in terms of what are we aiming for here. If my screen would cooperate, I can. Okay, there we go.
So Ashish, just for your information, I didn't hear any audio from that video.
Oh, you did not?
No.
Okay.
Maybe you can give us a little more context.
Sorry, something strange is going on. Hold on.
Before you share, if you can go down to the bottom of the screen and just to make sure you press select audio in the lower corners. It should be.
I'm going to stop sharing. I don't know what's going on. I'm going to stop sharing and I'm going to have Janet share. Can you make Janet the presenter?
Just a second.
I have no idea what's going on.
Just a second.
Can you hear me?
Yes, I'm just trying to.
Wesley, can you hear me?
Yes, I can. Yes, I can. Just a second. Janet, can you hear us?
Yes, Wesley, can you give me presenter privileges and I can share my screen?
Just a second.
think the YouTube video is gone on a loop. Very sorry about that. So Janet, if you could go to the sort of the slot number 3, we'll attach the YouTube video later on.
Sure. Yeah, I'll go straight to slide 3. No problem.
Let me leave and join.
We're seeing the screen.
Okay, hopefully the audio glitch is gone. Wesley, everything looks good at your end?
Yes.
Okay, sorry about that. Okay, we'll attach the video. Sorry, no idea why YouTube was on a video loop. So continuing on sort of what we were talking about, right? In reality, if you look at sort of the interdependency of what we were talking about, right? So if you look at sensors by themselves, not very interesting. So what we really are talking about here is when sensors attach themselves to networks, i.e. 5G with low latency. And if you miniaturize these sensors and put them on devices, with the ability to use a edge platform, edge storage, edge compute, and then deliver AI machine algorithms through analytics on top of this for a specific business process and automation, where you now combine, 3, 4, 5 different compute paradigms or algorithms with sort of like the next generation of networks with low latency. That's what we really are talking about. So to us, this is the confluence of individual technologies that are no longer siloed, but are becoming more and more connected and interdependent on a bunch of different, providers. So this is not about just, people that do the fab of AI-enabled chips with GPU. This is not just about people that provide the connectivity through 5G networks. This is the combination of a set of disparate technologies that brings this to bear. Janet, next slide, please. So if you look at sort of, where we are today, and if you look at sort of, why this is mainstream, really it is given us the ability to take IoT data, streaming sensor data from disparate sources. And I often get asked is, are you referring to Internet of Things? Are you referring to edge computing? Actually, I'm referring to Internet of Things, edge computing enabled by AI chips that get deployed at the censored machinery itself to be able to deliver, algorithms built on those data sets curated for outcomes, right? So it should be very evident when we use these technology drivers and we use the construct of data in motion, you don't end up at a static report. You end up with an action enabled through an algorithm to be taken at the device. And this could be around a connected supply chain where you are attempting to figure out, predictive failure, real-time optimization, inventory fulfillment, those things that you hear about that are enabled by connectivity of supply chains from the point of manufacturing to, to the point of disbursement. That could be a big box store where you're monitoring inventory outage as a result of censoring of the shelves. This could be, something as simple as fulfillment of the back office of any manufacturing facility. This could be about connected patient where you are doing proactive disease monitoring as a result of a wearable. So you may have heard about an Apple Watch or a surgically inserted device where somebody is attempting to remediate an adverse event from triggering an ER visit, right? So it could be blood pressure, it could be diabetes, it could be heart rate, it could be any of the above. And of course, one of the biggest applicabilities that we see around this is sports and entertainment venues where somebody's trying to personalize experience, which you saw in the video, right? So the video was almost, if you heard the audio or when you play back the audio, you'll see that it is about, getting personalized experience delivered to somebody that is at a sports event or somebody that is, wanting to figure out their multi-channel behavior, right? So when you buy a ticket at a Ticketmaster for a concert event or a sports event, and you end up, driving to the venue, how does your experience get personalized from the standpoint of when you enter the venue? That could be directing you to a parking spot. That could be customizing your experience by delivering you offers at seats or as you walk through a digital billboard that interfaces with you. all of the above. Next slide, please. So why now? If you ask me, there are some key drivers to it that I referred to earlier, right? AI chips, of course, with the ability to process, GPUs, where the amount of AI chips that are going to be shipped between now and sort of 2024 is going to be to the tune of about 1.5 billion chips, right? And you see the deployment of these chips becoming fairly mainstream in the ecosystem of consortiums for the usage of it. You've of course heard about the rollout of 5G networks, which is low latency to be able to deliver sort of video feeds and or any aspect of the data feeds that you'd need. It could be LiDAR data from a car that lets you, control sort of what the car does, whether that's in the car interfacing with another car on the street, the car interfacing with a human being, the car interfacing with other vehicle infrastructure, whatever it may be. I spoke a little bit about consumerization of edge devices. This is very, very big, when you look at sort of, what is transpiring from the standpoint of this sort of technology being built to be deployed at, very large scale. We saw this even during COVID, for sort of the increased need for, tracking and tracing, some of this went into play in the past 8 to 10 months, and of course, connectivity of devices, which is seeing explosive growth. So like I said, when I started this is not just about, connectivity or 5G or consumerization of devices. This is about a whole host of things that are coming together. Next slide, please, Janet. And if you see why, where this is headed to next, I'll spend a little time to tell you, the occurrence of these things in the industries or sectors that we see tied to the 5 value propositions on this page. We classify these 5, of course, there are more than 5. You might ask me, what about smart meter, smart grid? What about smart factory? Yes, as we continue to evolve sort of the business model around these, this is horizontally extensible. We see a lot of this adding to sort of what you see on the page. And I'll walk from left to right. So when you look at connected customer and you look at the applicability of the sectors that this plays in, you can see it's very true in automotive transportation. It's very true in retail consumer products. It's very true in telco, media, entertainment. It's very true in industrial products and construction, banking, capital markets, as well as technology. In retail consumer products, it's very B2C centric, where you are doing things tied to connected consumer. Like I gave the example of a smart venue, smart place, where you are attempting to marry multi-channel behavior to derive sort of people's experiences as they traverse the footprint. This is also true in retail and consumer products when you start to marry the interactions for somebody that goes to your website and then physically walks into the store. You marry the 2 interactions to do dynamic targeting, you do it for couponing, so on and so forth, right? In the B2B construct, when you look at this in sort of, manufacturing or supply chain, it's really about how do you manage your customers and consumers and suppliers, where you're curating first party, second party, third party data. If you look at connected patient, very true in healthcare life sciences, and very true around the future of chronic care disease management, where you are attempting to focus on biometric data being pumped through the consortium of this footprint, where you are determining an adverse event or condition through a biomarker, which could be a heart rate, or it could be blood pressure, or it could be your blood glucose sugar monitoring, in which you are attempting to notify not just the individual that has the variable that you are approaching an adverse event, but also a provider, be it a patient or a doctor, such that the individual does not end up in the ER. This is very true for medtech device manufacturers. This is very true also for providers and payers that are doing chronic care disease management. So very, very big applicability, a very big market for us in this place. Connected places I spoke a little bit about, and this is true for the next generation of smart stadiums that are being built for concert venue events, where you are attempting to figure out how do you guide an individual through a personalized experience from the time that they indicate the desire to go to an event. It could be an event, it could be triggered by a buy of a ticket at Ticketmaster. It could be determined through sort of you surfing for a website for a concert event venue and things of that sort, right? And then as we call it the different phases of the journey to get to an event, right? So from the time you buy the ticket to the time you go to the event to the time you leave the venue, right? Different levels of personalization, including assisting you with parking at the event if you drive to the event, including help you with concessions and couponing at the event, and including interacting with you when you leave the event. And the connected operations, very, very true in sort of like the back office operations of supply chain, and very predominant in the auto, transportation, manufacturing, retail, consumer manufacturing, and delivery, since most retail consumers deal with manufacturing that's done outside their supply chain. And finally, connected autonomous vehicles, and autonomous because connectivity through Tesla and some of the other cars has been ubiquitous for a while. But if you look at autonomous, which is also known as driverless cars, right? This is the ability to be able to ingest sensor data or LiDAR data, which maps objects in 3D to let you be able to sort of give the car very discrete directions on starting, stopping, being able to interact with other vehicles on the street, being able to interact with the infrastructure on the street. So in reality, if you start to look at the confluence of these business cases and you look at the applicability of the industry in these use cases, you can see why this is a very big business, and sort of where this is headed. Janet, next slide, please. So what does this actually look and feel like, in supply chain? We'll just play this video and hopefully you can hear audio this time. Same issue, Janet. I can't hear audio, so we'll let it play. Never mind. The voiceover here, in essence, this is a manufacturing facility, mirroring sort of what happens in fab where people are in protective suits. And in essence, you're trying to determine an adverse event that should not shut down a fab factory, right? So as you're probably aware, in a fab or consumer chip manufacturing industry, any down operations is billions of dollars of outage, right? So they're trying to hit, given sort of what's happening in the semiconductor chain of shortage of availability of chips, right? They've gone to 24/7 manufacturing. And this, in essence, is sort of mirroring the aspect of an error or a failure that happens in a fab plant as the chip moves through the different constructs or ability of the fab plant. And this is proactive notification to turn around and say there's an outage, and you need to do a parts or inventory fulfillment, that needs to happen in a manufacturing plant, independent of whether it's in Texas or Napa or San Jose. That needs to optimize inventory that is eventually going to come out of the supply chain to different places. So that's the genesis of the video with the voiceover. Apologies about the audio. So we'll let it finish, but hopefully you get the idea. Okay, next slide, please. This was sort of just the placemat that talked about what the voiceover I was giving you, right? So in essence, the challenge when you get into sort of, manufacturing that is that level of sophistication, this could be tied to even an aircraft. It doesn't have to be a fab plant, right? In essence, you're attempting to figure out is, as you need to proactively identify faulty parts to just really make sure that the facility, when it's censored, can trigger that data. The failure prediction or a proactive notification of an outage is the recommendation that triggers an engineer or the back end of a supply chain with an early warning signal to say, hey, we think a part is about to break that's going to shut down operations in a manufacturing plant, such that it triggers the inventory to be brought to the plant, such that you can start to do the things that you need to do to swap bits and parts out. This is sort of the placemat version of the video that you saw, right? And if you look at the deep dive on these and the end state architecture of these, I will talk through that shortly when we get to the next slide. So, what does the backend architecture of this look like? Janet, if you could go to the next slide, please. And I'll orient you to this picture, right? So we always dealt with the central compute instance, which in this picture is the gray fill box that is called an IoT platform or a big data platform. And it could be a central compute cloud instance where you do workloads today, right? What has fundamentally changed in what we're talking about in data and architecture is the workload has moved gradually to the left, to the device layer, to the edge layer, right? So the device is censored with either an actuator or a sensor that has the ability to communicate sort of the statistics of the device itself. It could be anything. It could be pressure, temperature, any sort of notification that is giving you sort of the sense of uptime or downtime of the device itself. And what has fundamentally changed in this architecture is you're not waiting for the entire workload to go to a central compute instance, right? So most people ask me, if you were to provide an outpost, an AWS outpost as a connectivity, doesn't it solve for it? It does solve for it, right? But most people don't want to ingress and accrue the ingress and egress costs of a 53 terabytes, which is sort of the average size of data that comes out of a single connected car every day, right? So if you look at sort of the edge layer is meant to not only reduce latency for the to and fro that is going to happen in this architecture if it were connected to a central compute instance. The edge layer is meant to reduce latency and also meant to reduce sort of like the to and fro of the workload to a central compute instance. So what you do in the edge layer now is you deploy the edge to have both storage as well as computability. So it's as close to the device as possible, such that you can do these things near real-time, which is sort of the low latency aspect of these workloads. Meaning, can we get to sort of like the device or edge behaving like a compute instance to be able to handle the data workload such that the AI chip with the algorithms is deployed at the edge. Now, this does not mean that you will not send some aspect of an outcome to a central compute instance, the gray box shown in the picture. What this means in essence is, depending upon the use case, some aspects of the architecture are at the device, some aspects of the architecture at the edge, some aspects of the architecture are in the big data platform itself. And if you look at the consumption layer to the right, this is very true now. The consumption layer is delivered through an API or microservices to the device, to the action, or oriented to an action. So the minute you make it algorithmic, right, it doesn't look like a static dashboard or report, which is very true for most of the work that we did. In the prior years when we spoke about data and analytics that was not AI enabled, you in essence built a static dashboard or a wireframe and you delivered the action, and a business analyst looked at that and said, well, now I understand what's transpiring. In these use cases, most of the workloads end up in an action. It could be an action to shut the device itself. It could be an action to trigger the back end of a supply chain parts or an inventory fulfillment, some of the above. So if you look at sort of the architecture of data in motion, the deployment architecture, it's not just a central compute instance, it's about the device, the edge, the connectivity, and the consumption layer. So hopefully that demystifies some of this. Janet, next slide, please. So as we sort of, get to put this into place, the question that I get asked is, how do people start to move for data in motion? So if you look at sort of opportunities that you already have, right? So it could be the 5 tranche of use cases that I shared with you, right? It is about sort of inventorying the core capabilities of the use case for the architecture picture that you just saw. Are you looking for that use case to be deployed through a consortium of a central compute instance with edge, with an AI-enabled chip? That's what puts into motion sort of how we manifest the architecture. And then we in Deloitte have stitched together the consortium of those use cases that I spoke about. So when we are dealing with OEMs that are doing connected autonomous vehicles, we're dealing with people that do have LiDAR data technology embedded in the ecosystem. We're dealing with people or software vendor partners that know how to index and label this data. We're dealing with people, the NVIDIAs of the world, that deploy these workloads into an AI-enabled chip for it to be able to train the algorithm so that when you deploy it in a Hive metastore and this starts to happen real time, how to write the algorithm or delve into that metastore for the data that has already been pre-tagged or pre-indexed. So to get moving on these use case, figure out the core characteristics of the use case, transpose that to the architecture, and then start the conversation about how do you stitch the ecosystem consortium together to make it happen. So that's sort of the genesis of it. Pretty fast 25 minutes of core construct, but happy to take any questions that you may have.
Sure. Very good, Ashish. Nice job. Great overview. I'm a consultant as well, and I see a lot of companies who want to do analytics on real-time data, on device data, IoT data. Something, the most common use case that comes up is predictive maintenance.
Right.
But it seems like it's a real stretch for companies to embrace this. So I'm wondering, where, outside of autonomous vehicles, which we know those are actually happening and companies that are producing them, but outside of that, where do you see the big traction for this kind of analytics happening?
We're seeing smart factories become pretty mainstream, right? So we have, at Deloitte, something that we built in Wichita State, Kansas, called Smart Factory, with the consortium of the Verizons of the world that provide 5G connectivity to that factory. The big manufacturers, i.e. Siemens and stuff of the world, that are attempting to sort of, build asset predictive maintenance into their operations. We did some of this work for a consortium of Caterpillar plants as well. So we see that mainstream. If you look at healthcare life sciences, patient disease monitoring through wearables is fairly predominant now. Some of it is happening through just the Apple Watches and the biometrics that are being generated as a result of it. But we've started to work with medtech device manufacturers that are going to do surgically inserted devices that's now going through FDA testing, where if I'll give the example, not that this is literal, like, when you have a surgically replaced knee that has the ability to communicate over low frequency Bluetooth with your handset, encrypted, of course. And then in essence, if something were to happen, as a result of that surgically inserted knee, you would be able to communicate with your orthopedic, and an orthopedic will be able to communicate with you as you sort of, go post a knee transplant to recovery through a physiotherapist and things of that sort. So I would say, at Hollywood Park Ram is sort of like where we built the big aspect of the smart venue, sort of the new stadium where the LA Rams play their football. So I would say for us in our portfolio, there are about, of the 5 things that I showed you, 4 are, our actual client use cases that have been built into the portfolio and operating at scale.
On the smart factory, do you see that extending into an intelligent supply chain?
Absolutely. I think that, if you look at sort of just the genesis of contract manufacturing and or supply chain and the aspect of manufacturing, it's very true that, it extends not into their own supply chain, but also into the supply chain of sort of the consortium of people that they work with, right? This is true, for any of the big whether you look at, Hewlett Packard that does this for servers, or Hewlett Packard that does this for PCs, or if you look at, any, whether it's a Cisco or a Hewlett Packard, it's true that the supply chains is not just them, the supply chains is them and their contract manufacturers. So I think supply chain is not very far behind from the standpoint of the sort of making this mainstream. I think the challenge is going to be is as you traverse supply chains and you look at the point of manufacturing that is global, how does sort of like the applicability of a 5G deployment globally bring this into the picture? Or do you do this through some, low frequency Bluetooth connectivity to a network that gives you the ability, because, once you put that on a container from the point of manufacturing, let's say you sensored the plant and you have connectivity in a plant and you can, observe the inventory in the plant, you would need connectivity on that container, on that ship that is going to, sail from, some manufacturing plant in China to the West Coast. So, before you offload it off the container and get 5G connectivity on US mainland. So I think, as you look at the applicability or where you're attempting to do this, how soon it becomes mainstream may be just the deployment of the things that need connectivity. So, but yeah, not too far behind. Hopefully you can still hear me, Wayne. All right. Janet, can you hear me?
Yes, I can hear you, Ashish.
Okay. Just making sure I'm not the only one on.
No worries.
Today's been not a good audiovisual day for us.
Wayne, can you hear us okay?
Oh, I'm sorry. I was talking and was muted in a different area. Here I was asking a question, another question. So, I know the goal is to move analytics closer and closer to the device itself, from the
That's
hub
correct.
to the edge to the device.
Correct.
And I'm wondering where we are in that trajectory. And you mentioned AI chip, and I must have missed this at the beginning, but I assume that's where you're embedding some kind of a analytics or algorithm on a chip inside the device itself, so it can act on its own events. maybe you could just give us a sense of where that might be applicable and where we are in the trajectory of moving analytics closer to the devices.
Yeah, so if you look at, absolutely. So if you look at a connected autonomous vehicle and you start to traverse the journey of a BMW or a Mercedes-Benz, and you'll see and you'll hear the word NVIDIA, and you'll find that NVIDIA is within the core consortium of the ecosystem where they are using sort of AI chips with the ability to do GPUs, processing units that can do graphics more than processing units that do CPU cycles, right? And you will see that today, they physically collect all that LiDAR data under the hood of the car, right? So the car is driving around with a storage device where all the LiDAR data goes under the hood of the car. If you fast forward, what the genesis of that collection and how it'll work is when they offload all that data. Today, they physically offload that data by basically pulling that storage device and attaching it to sort of a central compute instance, and then building the machine learning algorithms to be able to identify or tag LiDAR data or index LiDAR data to be able to, tell a stop sign from an individual crossing the street in front of the car. And what they're attempting to do is build the algorithms for both real-time events as well as simulated sort of data that they will add to that real-time event, such that when they eventually operationalize this and put the algorithm in the AI chip that sits in the car, when the car encounters the same event, it recognizes that is that event and knows what to do. So the AI-enabled chip that will carry the indexed LiDAR data or metadata that will then be operational would look like this, right? So today you're training the car with LiDAR data to be able to recognize certain vehicle-to-vehicle infrastructure, vehicle-to-human infrastructure, so on and so forth. When it becomes operational, the car knows when an individual crosses the street that the car should slow down and stop. When the car encounters a stop sign, the car knows it needs to stop, make sure that there's no, right of way and things of that sort. So that's sort of like, putting this into motion for when the AI chip gets deployed in the car itself, because no matter how much 5G connectivity you give to the car, it's probably virtually impossible or impractical to be able to do the to and fro motion from the car along with a low latency connection to a central compute instance, derive the action and give it back to the car. So, this is an example of where the AI-enabled chip deployment is progressing, right? We are at the point of working with OEMs to train or index data for the algorithms to be able to do what they need to do. And then once we get past sort of the core construct of what was real world data versus what simulated data, so that you have the full library of algorithms, then it goes in the car. When it goes in the car, the AI chip comes into play. So that's how it works.
Well, that is interesting. So that AI chip in an autonomous car is pulling and monitoring data from the LiDAR, right?
That's
and
right.
then its output then sounds like it could address any number of devices or instruments inside the car, right?
That's correct.
Yeah.
That's correct. Both the operations of the car itself, and sort of like the experience of as if you were driving the car itself. So it's not just about, some of that vehicle is, some of that vehicle data is also about, engine lights, engine functioning, oil change. So things that you're already used to through connectivity, right? Like, that's there today in most cars. But this is about like, taking the aspect of the 2D, 3D boxes that you draw around LiDAR data to be able to identify, just like a human being can, right? I mean, your brain is trained to be able to recognize an object when you drive a car, right? That's the attempt to teach an algorithm to be able to do exactly what the human mind does when you drive a car.
Right. So I'm going to have to assume that there's not just one AI chip in the car. There's probably a network of these chips, and they can all interact with each other. And maybe there's a AI chip of AI chips that kind of pulls it all together, right?
Very possible.
Yeah. Interesting. All right. So it sounds like this is advancing quite fast, and
it certainly is.
Yeah, leading edge companies working with you guys, obviously, and I think leading edge companies working in consortia with you guys. It sounds like
that is correct.
To do these very complex things, and are we out of the consortia phase? I mean, and moving into the I don't know, even leading adopter or mainstream phase. When do you think that's going to happen?
So, really the bets are being placed on what the consortium is going to look like, right? So without a doubt, right, if you look at sort of the ones that have enabled GPU processing, whether it was in AWS, right, that has happened, right? Now, if you look at sort of, it's not a big secret as to, Mercedes partnership with NVIDIA in the NVIDIA cloud to sort of build this, you're now starting to see that the stitching together the consortium, right? Where this is going to take a while is the standardization aspect, right? Because if you went and asked BMW the same question, you'll probably get a different answer for who they're going to enable through this AI chip infrastructure, right? So in reality, I think the bets are being placed on the ecosystem consortium. Certain organizations have been very successful in stitching this together because it is going to take not just a central compute cloud infrastructure provider, but it's going to take the people that do the the manufacturing of the LiDAR cameras, right? The people that do the indexing scale of the LiDAR data. That's a different piece of software, right? That doesn't come from a hyperscaler, right? And then if you look at the AI chips where all the workload happens, that's also a different consortium. So it is, this ecosystem is at least 6 to 7 players, including the hyperscalers, and that's the bets that is being placed for it to become mainstream. Certain use cases, like you said, and like I echoed to on autonomous vehicles, further along, because it takes a long while for that to manifest itself, and the others still, quite there in terms of the consortium being stitched together. And the trick in this thing, in essence, is to be part of the consortium, sort of to get a place in sort of that workload of what you will do to enable these services, which is where we come together, right? To bring 7, 8, 9 organizations together to stitch the scope of services and then to prototype it and industrialize it.
All right, some questions from the audience here. Are
Sure.
you able to speak about smart meters and the data in the context of an electric utility?
Yes, I can. So if you look at utilities and smart meter, smart grid, the aspect of, being able to read sort of the metering of the infrastructure very much in play, right? It's they're regulated entities. So if you ask me the same question about Exelon versus New York Power Authority, I'd have a different answer. So if you look at the different utilities, whether it's Southern California Edison or an Exelon or a New York Power Authority or a Tampa Electric, they're in different parts of the journey for the sort of metering of this infrastructure. I think that the cost of doing this, right, and sort of the regulation that is intending to make this mainstream is going to be 2 very big factors for when this sort of manifests itself universally, right? So right now, the reason I'm answering it the way I'm answering it is because of the fact that they're regulated and entities being at sort of not universal and being sort of where they are, some of them are further along. So there is, without a doubt, the smart metering aspect has happened. Now, if you turn around and ask me, like, will we never see a Texas-like failure that happened in a winter storm? I probably couldn't answer yes to that question, knowing sort of like, what needs to happen to utilities that do power distribution in Texas versus sort of the other part of the continental US. But a lot of asks for us about smart meter, smart utility is if the connectivity is there, through the back end of infrastructure that does power electric distribution, can you centralize sort of the workload to be able to do sort of the monitoring of, what's going over those wire lines, right? That is there. Now, the stitching together of, hundreds and hundreds of miles of this infrastructure is what is happening to sort of different levels of maturity, to say, and some will arrive before that. But I think the biggest trigger for that is going to be if there is a regulation that fast forwards this exercise to basically make it mandatory. I think that'll happen a lot faster. In California, sort of the biggest concern in essence is what it does during the summer season, the fire season, where there's a lot of electrical outages and they need a lot more proactive notification. So they are doing it for a different set of reasons, to prevent outages, to prevent fires from destroying infrastructure that they then become liable for. So if you looked at different geographies in the country, there are different trigger points, and I think the actions for what these public utilities are doing are also very different.
Great. I think you may have answered this in my initial question, but where do you think the industry is in terms of maturity scale of proof of concept to large scale deployment?
Yeah, depending upon the use case, it looks very different. Like I was talking about connected autonomous vehicles, right? The very fact that There is an autonomous vehicle with LiDAR data connected to it that you would probably see being tested in states, and states regulate sort of, what can get on the streets and stuff. So if you were to look at Michigan, in the state of Detroit, and if you looked at Motor City, there's a consortium of OEMs that are working with M-City to sort of put this into play, right? So, we ingest LiDAR data, we index tag LiDAR data for OEMs, right? So that is much further along. If you ask me, about some of the other use cases around connected consumer and retail, and it's happening through sort of frictionless retail, where a consortium is being stitched together to do the back end of supply chain fulfillment with the same constraints that I spoke about, right? Do they have 5G connectivity all over the globe, but they do manufacturing? Those are the things that probably slow down the implementation of, which factories or which facilities they can do this with. So I would say there are different parts of the journey. I think if I came back 12 months from now and had the same conversation, I would probably tell you some things that are happening, in beyond proof of concept, in the real world, versus others that are sort of like, being prototyped in proof of concept just as a result of the constraints of the evolution of the pillars that make it mainstream.
Now, you had mentioned consortia. Can you outline those again? I think you said there were 6 of them.
Yeah.
Certain.
Yeah. It's, if you go back to the architecture picture, it is sort of the left or the right of that picture, right? So you will need, if you're talking about the device, you would need something that senses the device itself. So if it's an actuator, or if it is.
Let me answer. So what do you mean when you say consortium? Because I'm thinking of a group of companies working together to solve.
I am too. So if you were to drop logos on this picture, then you would have a consortium that provides connectivity to the device. You would have somebody that provides 5G, like a Verizon. So the minute I logo this picture for a use case, that becomes the consortium for the use case, right? The central compute could become AWS with Outpost. The device connectivity could become something like a Siemens or whoever does device connectivity, or even a medtech device manufacturer.
Do these consortiums imply that these companies are kind of creating a strategic initiative together to build something?
That is correct.
Not just for one commercial use case, but for the industry as a whole?
That's correct. A set of use cases built around the specificity of the value prop pillars that I showed you. So if you went and asked this question around connected autonomous vehicle, the logos look very different. If you asked it for connected supply chain, the logos look very different.
Yeah. Absolutely. Okay. So a consortium for device layer, edge layer.
Correct. The
IoT platform,
the consumption layer, and anything else that you need, right? So there's at least 4 parts to this picture, 5 or 6, depending upon the use case.
Yeah. Okay. Good. Yeah, I was just looking at that chart. All right. Well, that's all the questions that I have had, and I don't see any more from the audience. Perhaps there's some closing remarks you'd like to make.
Absolutely. So, if this half hour didn't do justice to this conversation, you can absolutely reach out to me. That's my email, coordinates at the bottom, asverma@deloitte.com. We are doing this, with the different players that, I spoke a bit about, right? So to us, this is very mainstream. This is sort of the next big business that, we foresee in our portfolio from the standpoint of making this mainstream, and happy to, interact with you or help out, even ideation if that's what you're interested in as we build this together. So thank you, Wayne, and looking forward to the dialogue.
Excellent. Thank you.
Take care. Bye-bye.